Hey, hope you guys are all doing well. Today I'm going to walk you guys through how to make a password manager application in Python. So go ahead and open up your PyCharm. Go up here to File, New Project. You can name your project whatever. I'm just going to name it Password Manager. Deselect this Create My main.py welcome script. Go ahead and hit Create. Open it up here in this window, and then just give it a few moments for it to open up, create the environment and such. Now that your project is loaded up, under the venv of your project, go New, Python file. I'll just name it whatever. I'm going to name mine main. Open it here on the side and it should pop up, and we can get started with our password manager application. So first things first, what do we want the application to do? So I would like this application to take in the software name, the username, and the password that an individual would like to save. Let's say for like GitHub, they can't remember their password, so they type in, when they first make it, they type in GitHub, they type in their username, type in their password. The application here will do some encryption, save it to a file, and we'd be able to get that all later if we ever need, or if we ever forget our password. I guess we want to have two options. We want the option to add a new password, and we want the option to view all of the passwords, or maybe just view a password for software. So maybe you type in GitHub and then it will return the GitHub password. So let's start off here. Let's, I guess, make a menu for the user input. So let's go name equals input. Enter the name of the software you are using. You can do one for the username and one for the password. Perfect. Now let's throw this in a menu, because I guess this will be the only the option we want when you want to add a new password. So let's just instantiate a blank menu here, and then let's say while menu, since we only want two options, while menu is not equal to 1, or menu is not equal to 2, then display the menu, which will say would you like to save a new password or view your old ones? Perfect. And we can say if menu is equal to 1, it will display these options. And if the menu is equal to 2, we'll just say print display passwords, because we don't know, or we don't have any code for that yet. And let's even make an exit function too. So if the menu option is equal to 3, it will just exit. And up here we can say exit. Nice. Let's go ahead and test run that. So we can go ahead and run that and test it out. So if we went and we hit 1, number 1 will pop up. So software we are using, let's just say some random stuff. We'll say site, username, it can be the super student. These don't really matter because they're not going anywhere, but it works perfect. It goes right back to the menu. If we hit 2, it will just say display passwords. Yep. And then, oops. If we hit 3, it'll just exit the application. Let's do the saving to a file. So let's save all the data to the file, and then let's get displaying that data. So to open a file in Python is relatively easy. Just type in any variable. You could do name f or file, name it open or equals open, and then the name of the file. So I will do secure password data.txt followed by a comma, and then the option you want to open that file in. So we're going to open it in append mode. You can open it in write, create, or read. But for this application, we're going to do append. And then to write to the file, just do file.write, or whatever the name of your variable is, .write. And then whatever you want to write to the file. So we wanted to write the software name, the username, and the password. And then of course, close the file to stop any memory leakage. And let's go ahead and try running that and see if it creates our file. So let's input a new password. Let's just do test software, user, and pass. Oh, and it gives us an error. It says it takes exactly 1 argument. That is because we did commas rather than plus, which is what should have been done. So let's try that again. Test, user, pass. And it goes through. And we see the txt is made up here. We can go ahead and open that up. And there it is, test, user, pass. So our username here, password here, and the software name test. Whoops. So we know that's working well. So before we go on to reading in from this file, let's make a few changes. So we're going to want to separate the software name, the username, and the password from each other. And then we're going to want to create a new line each time a line is entered. So the next entry is always on a new line. So back on this file.write line, let's create a delimiter to put between our entries here. So I'm gonna do a semicolon and a pipe. The reason I'm doing 2 characters is because like if you enter a comma right within here and then you just do a regular comma separated value, if one of your software name, username, or passwords has a comma in it, then your application, it will just break because it will try and take the wrong element from your list. So and then at the end here, let's do a \n to create a new line at the end of that. Perfect. And then within menu 2, to read in the files as of now, we're going to want to open the file again. So file equals open. Choose that same file. This time let's open it in read mode. And then we're going to want to read each line in this file. Oops, I forgot to close that. We want to read each line in this file. So let's say, let's make a loop for each line. So for I in file, we can say like either the software name, username, or password is the line separated by that semicolon and pipe combination. So I will read in this line. All right, let's delete this for now. Run it again. Input a new password. Just put in something silly. Super username, super password. And then let's exit there. So we'll have our new pieces of information here separated by those combos, and there's a new line at the end. Now when we read it in, we're going to want to say print data at position 0, data position 1, data position 2. So this should print the software name, username, then the password. Let's test that out. Yep, so there's SATE, super username, super password. And of course, these have been removed thanks to the split function. So there's an easy way to view it from the file. Now to clean this up real quick, let's just add in some other stuff up here. Make it a little table, so I'll do software, username, password, and then let's separate each one of these by a couple tabs. Perfect. Let's try that again. So it nicely displays everything. Now let's get rid of this data here, the sample data. Let's run the application again, and nothing should appear this time. Perfect. Other than, of course, yeah, the software username password just put. Just goes straight back to the menu. So everything's working well as of now. Now to create a function within Python, it's relatively simple. Just let's start our function with def to define a function, and then within our encryption function, we're going to want to add a input parameter. So the input parameter is going to be either the password, the username, or the software, because we're going to want to encrypt all that data to make sure no one knows anything about anything. So let's take in the data, and let's also take in a key value or a shift. And let's create our empty string here. Within that function. So for this application, I'm going to be using a Caesar cipher encryption. So to create an encryption, algorithm, I'm going to be doing a function within Python. So to create a function, you just start with def, then the name of the function, so def encrypt, and then I'm going to take in some input parameters, some data, and a key value or a shift value. So we're going to loop through the data, so we're going to want each character within let's say the password, right? In the Caesar cipher, the way it works is if the character is like a B, the character would be shifted based on this value that many characters in the alphabet. So if it was a B and the shift value was 2, it would go from a C to a D, so the B would become a D, right? If the shift was 1 and the character was an A, then the character would become a B, if that makes sense. So the way we're going to do that, we're going to take the length of the the data. I'm going to take the length of the data. So for each character, this pretty much says for each character in there, we're going to say so assign car to each position. And if that character is an uppercase character, we're going to perform some encryption. So we need to make a string, let's say encrypted string. Let's just make it blank up here, and we're going to want to append this character to the encrypted string. So this is the string we're going to return at the end of this function as the actual string that's being encrypted. So the way we're going to do this is we're going to transfer the character into the number value for that character. So chr, so cur ord, that takes whatever is within here, takes car, and it takes that character's number value rather than its like letter value. So every character has an assigned number pretty much. So if you take that number and you add it by the shift value, and for uppercase characters you need to subtract 65. If you take this character value and then subtract 65, that will get the correct value, right? And then you shift it that many characters up in the alphabet. So back here, whenever we're encrypting, we need to make a shift value. Let's make it just 2 for now. And then we can finish the statement off. So we need to modulus by 26, so that is per each character in the sequence of characters. So this is A to Z in all capitals. So there's 26 characters. And we need to also test if the character is lowercase. So we can say character dot is lower. Add in the same calculations plus shift. For lowercase, you minus 97, and then again there's 26 characters in the alphabet, so you modulus by 26. And so for the Caesar cipher, you need to actually check if it is a number as well, because if you just check if it's an uppercase or lowercase. If it's a number, it will just break. So we need to check if it's a number. Oops, I think I've been doing this backwards too. Nope, I'm good. Alright. So we need to check if it is a digit. So the way to do that, we can create a quick number variable, assign it to an int of car of the character that this is at, and then we simply just shift it over, using the shift, and then modulus, since there's only 0 to 9 rather than A to Z, you do 10 instead of 26. Let's get all that in there, and then yeah, you just simply add number to that encrypted string, return encrypted. That should work the way that we want it. Oh, that could be bad. It was resetting the string every time, so we want to do it outside. So we can go ahead and try this out and see if it encrypts our data. So let's input a new password. Oh, before we do this, let's go ahead and stop this application. We actually need to call our function. So down here, when we do our file write to the file, we can actually now say encrypt and replace the data input parameter with the actual piece of data. So for the first one, it's software name. For the second one, it will be of course username, and then comma shift, of course the shift value. We can set this to be like 3, 4, 5, 6, 2, 1, 7, 9, like any number to 25 or 26. I think any number you want. That's how many characters it will shift in the alphabet. So let's now encrypt the password, and that should be good. Let's go ahead and run that and put a new password. The software, let's do SATE. So we need to make sure we have a capital letter, a lowercase, and a number. Oh, as well as a special character, which will probably break this application as of right now, because we did not define what to do for a special character. So let's just leave that out for now. So let's do pass123 user and SATE. Okay, we got problem on line 11, encrypted plus equals number, can only concatenate string. So let's cast that over to a string, and let's try that again. Let's do the same inputs, make sure it didn't save. Yep. And then pass123. Alright, so it works. So that was the problem. Let's go ahead. Everything has been encoded. So we have our, what is it? Our shift of 5. So S turns into X. So S Q R S T U V W X. That's 5. Look at that. That's crazy. A to F. A B C D E F. That's crazy. I to N. J K L M N. Oh my goodness. That's 5. Absolutely crazy. T to Y. That's crazy. SATE. That's been encrypted. So now say that you don't know what the heck any of this means. You need to decrypt that data. You need to be able to actually remember what that is, because if we go ahead and view our passwords right now, it's just going to give us that encrypted data. So we're going to want to somehow decrypt this data. First, let's actually try and input a password with a character like that, like a special character, and see if it explodes. No, but it didn't actually save in any information. So that's not what we want. Yeah, it doesn't. So we're going to want in our encryption to have a final else. So if it's not a number, it's not a lowercase, it's not uppercase, we don't want it to just yeet that away. We want to actually just add it. Just add it. Like, if it's a symbol, it's a symbol. You know, we don't need to encrypt that, right? So let's just add car. So in this case, if we input a new software, let's say we're using LinkedIn or something, and then username is whatever, and then our password is like super awesome exclamation mark 2 3, right? And we go and view what that says. The exclamation marks are still in the password, so that's exactly what we want. Perfect. So now to decrypt the data, so we don't actually just lose it, or if we forget the key, then we'll still be able to access it. Let's make a decryptor. So along the same lines of our encryptor, let's actually just copy and paste that. Why not? And then change every occurrence of encrypted to decrypted. And then all we need to do is reverse our shift. So instead of going up in the alphabet, it goes back in the alphabet. So just replace those with a minus. In reality, we should be good to go. Just need to add our decrypt function down here into our data, into our read section. So let's add that in. Getting the shift there. Let's also define shift here to make sure it's the same. Final one, decrypt, shift. Perfect. So we should now, last time we ran this, we got XFNY, ZXJW, UFXX 678, bunch of random crap. Now if we run it with our decrypt, theoretically it should appear with the original password. And look at that. There it is. Now this works very well as a little password manager application. If anyone tries to steal your file, that's all they get is just a bunch of gibberish, unless they know that you're using a Caesar cipher and that you're using the key of 5. There's no way that they can get this information. Just make sure that this application is safe, really. So like, make sure someone can't walk on up to your computer for some reason. Open up your password manager, run it, hit view passwords, and then sit at your screen and write them all down. So just don't, as long as you don't let someone do that. This is a pretty great app. Very simple to code. Only 50 lines. Yeah. That's about it for my application. Thank you very much for tuning in to this video. Thanks for reading the blog post. Hope you guys stick around for my future projects. And thanks for checking out this video. Take care. See ya.